Alright, there's another video for 3HT, and this one is about exercise 5. It says the height of the steel cables of the suspension bridge shown in this figure are given by this formula. So we see a formula here, and X and H are in meters. The space between the towers P and Q is divided in 6 equidistant sections. That means that these sections are all the same length. So this section is the same length as this length, and that, and that, and that. So the difference between those lines is the same everywhere. And the road surface is 5 meters above the water. So that's 5. Okay. Question A says, calculate the height of the towers relative to the water. Alright. Well, here it says, it's a bit hard to see here, so maybe in the book it's more clear because you have these red lines here. But we can see that P is here on the y-axis, so the x is 0 there. So if you want to know how high P is, then you have to fill in 0 in the formulas. That's what we're going to do. So I'm going to say here we're going to fill in 0. So you have 0.007 times 0 squared minus 1.05 times 0 and then plus 60. So it's going to be 60. But the question does say calculate the height of the towers relative to the water. And here we have the x-axis, right? But the water is 5 meters below the x-axis. That means that P is 65 meters above the water. So you need to do 60 plus 5 to get 65 meters. That's how high the tower is compared to the water level. We're going to go to question B. It says calculate the height of the lowest point of the steel cable relative to the water. Alright, so here we have the lowest point. Well, you can see that from P to Q, that's 150 meters. That means in the middle, here we have 75. So we're going to fill in 75 into the formula. So the height is 0.007 times 75 squared minus 1.05 times 75 and then plus 60. Now this is a bit hard to do out of my head, so here I have a calculator, right? So let me just clear this whole thing. So let me see what we need to calculate actually. We do 0.007 times 75 squared and then minus 1.05 times 75 and then plus 60. And then we get 20.625, but that's compared to the x-axis and we want to compare it to the water, so we have to do 20.625 plus 5 meters, so the answer is 25.625 meters. And then we're going to go to question C. It says here C, calculate the length of steel cable AB. Alright, so here we have A and here we have B, and so this is steel cable AB, that's this one over here. So I want to know what the x coordinate is, because if you fill the x coordinate into the formula, you know how high point A is. Well, we have 6 bars over here and 6 bars or 6 distances, like 1, 2, 3, 4, 5, 6. That's also 150 meters. That means that the difference between 2 of those bars is 25 meters. So here the x coordinate is 25. So we're going to fill in x equals 25. So then the height is 0.007 times 25 squared minus 1.05 times 25 and then plus 60. Now if I type this in real quick, let me just do that over here, then let me see what we get. Then I get 38.125, and that's actually also the length of AB. We don't have to add 5 to it because that would be if you want to know the distance compared to the water, but in this case we don't. So it's just 38.125 meters, and that's the answer for 5C. So thank you for watching, and I'll see you later.